So today's lesson is going to focus on topographic maps, but our book starts off with an overview about ways to represent Earth's surface, which is a map. Most of y'all are pretty familiar with maps. Google Maps is probably the one you're most familiar with. And maps usually show, the ones you're used to most probably looking at, show roads and directions for how to get from one place to another. But there are other types of maps and other ways we can look at Earth's surface. Something that's not a map, but we still find very useful, are aerial images. So if you ever go to Google Earth, you've seen aerial images, satellite images. These are images that are taken from space by objects orbiting Earth, which is satellites. So here's an example of a satellite image. Another type of map, not too important for what we're talking about today, but geologic maps show rock types and ages like this map down here. But what we're really focusing on today are topographic maps. So these are some of your vocabulary words for the test. Topography, the shape and the size of land features on Earth's surface. A topographic map shows the shape of Earth's surface with lines that represent different elevations. There's some details there about how these are made and how they're used. Now, most of the lines on a topographic map are called contour lines. Map are called the contour lines. Those are the circles that you see that you drew the other day and that you see on the map on this page. A contour line connects points of equal elevation. So on the right, this map, each line traces along the elevation. The shapes that form by the contour lines show the shape of the land. The contour lines are smooth and curved. They're characteristics that you learned about the other day when we read what's important about contour maps, the rules of contour maps. You have a question on this page asking to compare the difference between the top photo to the topographic map. These both show the same place. So the question is, what can you see on the topographic map that you cannot see on the photograph? Well, one thing is you can see the exact elevation. We can tell exactly how high above sea level each part of this island is. You can also see the shape of areas not shown in the photo. The shape of slopes not shown in photos. So some rules for contouring, reviewing what you learned before. All the points along a contour line represent a single elevation. A contour line has to be a complete closed loop. Sometimes it'll go off the page, but it always closes either on or off the page. They don't fork. They don't split apart. They never cross. And the spacing depends on how steep it is. Closely spaced lines represent a steep slope. Lines spaced further apart represent a gentle slope. You also really need to notice the units used on the topographic map. For example, on this topographic map, each one is marked 500, 600, 700. The X at the top shows the highest point on this map, which is 715. I'm thinking it must be feet. They don't actually identify it on that map. So this section is just going on to mention that you should notice some of the other markings on the map, points, lines, area symbols. You have to analyze the map to find out what it's representing. The point could be an X, like I showed you on the previous map. It could be a dot or a square. Points mark things, like the highest mountain peak. It might mark buildings. Lines might be drawn on there in addition to the contour lines that show rivers, trails, borders, roads. You might see some hiking trails on there. They might be shown with a dashed line. So often vegetation is represented with green. You have to look at each map and figure out what is shown on that map. And, is there a key to help you, or do you just have to figure it out on your own? Question number 8 wants to know which has steeper banks, Dad's Creek or Jeff Davis Creek? So the first thing you have to do to answer that is to find Dad's Creek. Notice the contour lines around Dad's Creek. We come over here and we find just Jeff Davis Creek. Notice those contour lines. So if we're being asked which one is steeper, think about what kind of contour lines show a steep bank. The closer the contour line, the steeper the bank. Therefore, Jeff Davis Creek has the steeper bank. So the answer would be Jeff Davis Creek because the contour lines are closer together. On the next one, you needed to circle the elevations of two neighboring index contours. I chose 4200 and 4100. These are index contours because they're the darker lines. Subtract the smaller elevation from the larger elevation in the space below. You could probably do that in your mind, but it's 100. Count how many spaces are between the two index contours you circled. Write this number below. There are 1, 2, 3, 4, 5. We're counting the spaces, not the lines. Since there are 5, we can divide 100 divided by 5, the difference between these two, divided by how many spaces there are between them, and we can figure out that each line is 20 foot. You can do it that way. You can do guess and check, but you need to guess and check, not just guess. This section will help you with understanding how you can figure out land features that are on the topographic map. I really like this picture because it shows this mountain and it also shows the contour lines overlying it, which you'll never see that anywhere except in an instructional textbook like this. So some rules that we talked about the other day: contour lines that form small closed circle may represent a hill or a mountain peak, like what you put into your journal yesterday. Closed circles may also represent a depression, which is a bowl-shaped feature. But remember that they have those hatchers, those short lines inside the circle that point to the bottom of the depression. Remember, if they cross a valley or a stream, they have a V shape that points to the higher elevation, that V shape points upstream. If the lines show a ridge, they might form a V shape. In that case, if it's a ridge, the V shape would point downhill. Contour lines that are stacked or very close together may represent a cliff or a road cut. Remember, if there are small lines inside, it's a depression. So that's showing something like a volcanic crater. It's asking you to identify a steep cliff, a river in a flat vegetated area, a stream, valley, or a peak. On this kind of question, go with what you know. That the steep cliff is going to have very close together lines. The river in a flat vegetated area is going to have far away lines. A peak is going to be a circle. So letter D is the mountain peak. Letter C is the stream valley. You can actually even see the stream in this one. Letter A shows a cliff. You can see how close those lines are. They're practically on top of each other. El Capitan is a feature found in Yosemite National Park. It's actually a rock climber's dream. The guy who founded Patagonia, he actually was one of the first people to make this a climbing mecca. And letter B, that's the river in the flat vegetated area. You can see that there's hardly any contour lines because the area is so flat. I think this page was a little bit challenging. It was trying to get you to see if you were taking a hike, what kind of elevation change you would have in that hike, or if you were riding your bike or any other outdoor activity. So you had to find the distance of the trip you were going to take. Then you had to find the change in elevation. So they did that by just measuring with their finger. That point A to B was 1.5 miles. So we just do this. Actually, use your fingers. That's about half a mile. Take that same distance and just measure 1, 2, 3. It's an approximation. So it's about 3 times a half, which is 1.5 miles. Then they looked at the beginning elevation and the ending elevation, and they subtracted to find the total elevation. Once they knew the total elevation, they knew that was a change of 1,800 feet. If they divide it by how long that distance was, 1.5 miles, they figure out that it's 1,200 feet per mile change. That's a pretty serious hike. That's going to be pretty tough. Now we're going to do the same thing with point C to D. So if you look at step 1 on the next page, it tells you to first use the map scale to estimate the distance from point C to D and write the distance below. So use your fingers now to measure that. Make sure you have it right. And you should have gotten about 1 mile. Then you have to estimate the elevations from C to D, and you write your estimates below for C and D. It's not so simple, is it? Because point D is on a contour line that's not marked what it is. So we're going to have to figure it out. It takes a little bit of work to figure it out, but it's actually 9,000. This is 9,200. And if we count 8,400, 86, 88, 9,000, 9,200, that's how we can figure it out. So it should be 9,400 for letter D. Yeah, that 9,400. For letter C, it's actually 9,000. That's a little bit easier because it's already marked. Then we just subtract those to find the difference. 9,400 minus 9,000, and we get 400-foot difference. It's only it's hiking for a mile, so it's 400 divided by 1, and it's a 400-foot change per mile. Not nearly as strenuous as 1,200-foot change per mile. That concludes our lesson on topography. I'll post this on Schoology, so if you need to review it, you can. Bye.